Welcome to Framework, the podcast that makes the NIST cybersecurity framework practical, engaging, and accessible. Whether you're a cybersecurity professional, business leader, or simply curious about how organizations defend against cyber threats, this series is for you. This podcast is inspired by a comprehensive guide to the NIST Cybersecurity Framework 2.0, a best-selling resource written by cybersecurity expert Dr. Jason Edwards and trusted by professionals worldwide. In each episode, we'll leverage a few insights from Jason's extensive book to dive deep into CSF 2.0, unpacking every function, category, and subcategory with real-world applications you can immediately use. If you're enjoying this episode and want to learn more, head over to cyberauthor.me to grab your copy of the book and access additional resources to enhance your cybersecurity journey. You can also visit baremetalcyber.com, where over 2 million people last year explored expert insights, articles, and practical tools across a wide range of cybersecurity topics. ID.AM-02, Managing Software and Service Inventories. ID.AM-02 ensures that organizations maintain an up-to-date inventory of all software applications and services within their infrastructure, allowing for effective cybersecurity risk management, compliance enforcement, and security policy adherence. This subcategory belongs to the Identify function within the National Institute of Standards and Technology Cybersecurity Framework, version 2.0, emphasizing that tracking software assets is critical to detecting vulnerabilities, preventing unauthorized applications from being introduced into enterprise environments, and ensuring secure configuration management. Without structured software and service inventory management, organizations risk running unpatched or unsupported applications, allowing unauthorized software into production environments, and increasing exposure to cybersecurity threats such as malware infections and data breaches. By implementing structured software and service inventory management, organizations ensure that every software application and digital service is accounted for, assessed for security risks, and aligned with cybersecurity policies. A structured approach to software tracking enables organizations to detect shadow IT, prevent software license violations. Organizations that deploy real-time software discovery tools, enforce structured inventory management policies, and integrate software asset tracking into cybersecurity governance improve their ability to enhance data protection, prevent software supply chain risks, and maintain regulatory compliance. Multiple stakeholders play a role in managing software and service inventories. Cybersecurity and IT operations teams are responsible for tracking software deployments, identifying unauthorized applications, and enforcing software security policies. Procurement and software asset management teams ensure that only approved software is acquired, deployed, and maintained within enterprise environments. Compliance and risk management officers ensure that software and service tracking aligns with regulatory cybersecurity frameworks, legal data protection requirements, and enterprise security governance models. Software and service inventory management is implemented through structured asset tracking policies, real-time software discovery tools, and continuous software compliance verification mechanisms. This includes deploying automated software asset monitoring platforms, enforcing strict application approval procedures, and ensuring that software inventories are regularly updated with security and compliance status. Organizations that fail to track software and service inventories effectively risk running unmonitored applications, exposing networks to supply chain vulnerabilities, and facing legal repercussions due to software license mismanagement. Several key terms define software and service inventory management and its role in cybersecurity governance. Software Asset Management, SAM, ensures that organizations maintain a structured and continuously updated record of all software applications within their environment. Service discovery and compliance audits require organizations to track external and internal software services, ensuring they meet compliance standards. Unauthorized software detection enables organizations to identify and remove unapproved applications before they become security risks. Regulatory compliance for software tracking mandates that organizations align software inventory management with industry cybersecurity laws. ensuring visibility into all applications and services. Lifecycle management and decommissioning ensures that organizations properly track software from acquisition to retirement, preventing outdated applications from becoming security liabilities. Challenges in managing software and service inventories often lead to incomplete application tracking, weak enforcement of software security policies, and failure to integrate software asset management into broader cybersecurity risk management frameworks. One common issue is lack of real-time visibility into software deployments, where organizations fail to continuously monitor application activity, leading to unapproved software being installed and operated without security oversight. Another issue is failure to track software beyond initial procurement, where organizations lack structured processes for updating software inventories as applications are updated, deprecated, or replaced. Some organizations mistakenly believe that software inventory management is only necessary for licensed applications, without recognizing that even open source and internally developed software must be monitored for security risks. When organizations implement structured software and service inventory management, they enhance cybersecurity resilience, improve software security compliance, and ensure that all applications remain protected against cyber threats. A structured software asset management framework ensures that endpoint security remains in force, software visibility remains comprehensive, and cybersecurity risk mitigation strategies remain aligned with enterprise governance requirements. Organizations that implement structured software tracking policies, enforce automated software discovery mechanisms, and integrate software monitoring into enterprise security strategies develop a comprehensive cybersecurity framework that strengthens application security resilience and reduces software asset management risks proactively. Organizations that fail to manage software and service inventories effectively face significant cybersecurity, operational, and compliance risks. Without structured software asset management, businesses risk running outdated or vulnerable applications, exposing networks to security threats, and failing to maintain compliance with licensing agreements and regulatory requirements. A common issue is reliance on manual software tracking methods, where organizations attempt to document software usage manually but lack automated tools to detect unapproved applications, leading to blind spots in security governance. Another major challenge is failure to integrate software inventory management with security patching processes, where organizations do not maintain visibility into outdated software versions, increasing exposure to cyber attacks exploiting known vulnerabilities. By implementing structured software and service inventory management, organizations ensure that every application remains monitored, security risks are proactively addressed, and compliance requirements are met. A well-defined software inventory management framework improves visibility into software usage, reduces unauthorized application deployment, and ensures that security controls are consistently applied across all digital services. Organizations that deploy automated software tracking tools, enforce strict software approval workflows, and integrate application security assessments into enterprise risk management strategies improve their ability to identify, prevent, and mitigate software cybersecurity risks efficiently. At the partial tier, organizations lack structured software inventory management policies, leading to inconsistent tracking of applications, weak enforcement of security controls, and unmanaged software licenses creating potential compliance risks. Software asset tracking is handled reactively, with organizations only addressing application security issues after a cybersecurity incident occurs. A small business at this level may allow employees to download and install software without security oversight, increasing the risk of running outdated, unauthorized, or malicious applications. At the risk-informed tier, organizations begin to develop structured software asset management policies, ensuring that business-critical applications are inventoried and monitored. However, software tracking efforts may still be limited, with inconsistent enforcement of software security policies across different business units. A mid-sized retail company at this level may maintain a software inventory for customer-facing applications, but fail to track third-party cloud services used for internal operations, creating security gaps in supply chain risk management. At the repeatable tier, organizations implement a fully structured software and service inventory framework, ensuring that all applications are continuously monitored, security policies are applied consistently, and software asset compliance remains aligned with enterprise risk management strategies. Software security governance is formalized, with leadership actively involved in reviewing application security policies and ensuring that software inventory tracking remains in force across all organizational services. A financial institution at this stage may require all business-critical applications, cloud-based services, and third-party vendor software to be integrated into a centralized software asset management system, ensuring compliance with financial cybersecurity regulations. At the adaptive tier, organizations employ AI-driven software asset discovery platforms, predictive software risk analytics, and automated compliance enforcement solutions to dynamically track software usage, detect unauthorized applications, and enforce software security policies in real time. Software asset security management is fully integrated into enterprise cybersecurity governance, ensuring that software inventory tracking, service security assessments, and application lifecycle management strategies remain continuously optimized. A multinational healthcare organization at this level may use AI-powered software monitoring tools to assess application vulnerabilities, enforce automated patching workflows, and dynamically adjust software tracking policies based on evolving cybersecurity threats. Managing software and service inventories aligns with multiple controls in the National Institute of Standards and Technology, Special Publication 800-53, ensuring that organizations implement structured software security tracking frameworks and dynamic application compliance verification models. One key control is CM-8, System Component Inventory, which requires organizations to maintain an accurate and up-to-date inventory of all software components, ensuring that all applications are monitored and managed securely. A global technology firm implementing this control may deploy automated software discovery tools that continuously scan enterprise environments for unauthorized applications, ensuring compliance with internal security policies. Another key control is SI-2, flaw remediation, which mandates that organizations track all software vulnerabilities and apply timely security updates to reduce exposure to cyber threats. A financial institution implementing this control may integrate its software inventory management system with a vulnerability scanning tool, ensuring that all applications are regularly assessed for security flaws and patched according to risk severity. Managing software and service inventories also aligns with SC-13 cryptographic protection, which requires organizations to ensure that all software applications handling sensitive data implement strong encryption mechanisms and comply with cryptographic security standards. This control ensures that organizations maintain oversight of software handling encryption keys, certificates, and protected data, preventing security misconfigurations or outdated cryptographic protocol. A multinational healthcare provider implementing this control may track all software applications that process electronic health records, ensuring that they comply with advanced encryption standards and industry security regulation. These controls can be adapted based on organizational size, industry, and cybersecurity maturity. A small business may implement basic software inventory tracking measures, ensuring that only pre-approved applications are installed on company-owned devices and that outdated software is decommissioned. A large enterprise may deploy AI-driven software discovery platforms, automated vulnerability management systems, and predictive software security analytics to ensure that software tracking remains dynamic, continuously updated, and optimized for real-time cybersecurity threat detection. Organizations in highly regulated industries such as banking, healthcare, and government contracting may require continuous third-party software security audits, legally mandated compliance reporting, and zero-trust application control frameworks to ensure strict software security governance. Auditors assess software and service inventory management by reviewing whether organizations have structured, documented, and continuously enforced software asset management frameworks. They evaluate whether organizations implement structured software tracking models, enforce real-time application monitoring policies, and integrate software security verification measures into enterprise-wide cybersecurity governance strategies. If an organization fails to track software and service inventories effectively, Auditors may issue findings highlighting gaps in software security oversight, weak enforcement of software asset compliance, and failure to align software inventory management with enterprise cybersecurity risk mitigation strategies. To verify compliance, auditors seek specific types of evidence. Software inventory reports and structured application tracking documentation demonstrate that organizations formally define and enforce structured software asset management governance models. Application security compliance tracking records and software vulnerability audit reports provide insights into whether organizations proactively monitor software security performance and refine application tracking policies based on real-time cybersecurity risk intelligence. Incident response evaluations related to software security failures and third-party application risk mitigation reports show whether organizations effectively track vendor software security risks, ensuring that supplier software security governance remains continuously enforced. A compliance success scenario could involve a global financial institution that undergoes an audit and provides evidence that software inventory management processes are fully integrated into cybersecurity operations, ensuring that all business applications are continuously monitored. Third-party software security compliance frameworks are actively enforced, and software asset security governance remains aligned with regulatory cybersecurity risk management standards. Auditors confirm that application security risks are systematically managed, software asset compliance is continuously enforced, and software inventory tracking governance aligns with enterprise cybersecurity risk mitigation strategies. In contrast, an organization that fails to implement structured software asset tracking frameworks, neglects application security compliance verification, or lacks formalized software inventory management oversight models may receive audit findings for poor software risk management, weak third-party cybersecurity asset tracking enforcement, and failure to integrate software security risk assessments into enterprise cybersecurity governance strategies. Organizations face multiple barriers in ensuring that software and service inventory management remains continuous and effective. One major challenge is lack of automation in software tracking, where organizations fail to implement real-time software monitoring tools, leading to delayed detection of unauthorized or outdated applications. Another challenge is failure to align software inventory tracking with regulatory compliance requirements, where organizations lack predefined third-party software security verification measures, increasing exposure to compliance violations and regulatory fines. A final challenge is over-reliance on manual software asset management, where organizations depend on outdated tracking methods instead of deploying automated software compliance enforcement mechanisms, leading to potential oversights in application security risk management. Organizations can overcome these barriers by developing structured software asset tracking frameworks, ensuring that application security compliance monitoring remains continuously enforced, and integrating software inventory risk assessments into enterprise-wide cybersecurity governance strategies. Investing in automated software security compliance tracking platforms, predictive software risk assessment models, and AI-driven application monitoring solutions ensures that organizations dynamically assess, monitor, and refine software and service inventory management strategies in real time. Standardizing software security governance methodologies across departments, subsidiaries, and external business partners ensures that application security policies are consistently applied, reducing exposure to software-based cyber threats and strengthening enterprise-wide security resilience. By embedding software and service inventory management into enterprise cybersecurity governance strategies, organizations enhance application security accountability, improve regulatory compliance, and ensure sustainable software asset risk management strategies across evolving cybersecurity landscapes. That wraps up today's discussion on framework. Don't stop here. Head over to cyberauthor.me to explore more cybersecurity topics and discover a best-selling book covering NIST and other critical cyber frameworks. Please like, rate, and review this episode on Apple and Spotify. Until next time, remember that knowledge is power.